A fifth grader is projected with a purely horizontal velocity from a 7.25 meter tall cliff, lands 6.8 meters from the base of the cliff, right? So that's off they go. And we know that this is 6.8 meters and that the cliff is 7.25 meters tall, right? So purely horizontal velocity means that this velocity is 0. There's no vertical velocity, right? This is something, right? But we don't know what it is. Let's see, 7.25 meters tall. So from the top of the cliff down, it's 7.25 down, right? Don't forget that minus sign, right? All right, and then they land 6.8 meters from the base of the cliff. So the horizontal displacement is 6.80 meters, right? The acceleration here is 0. The acceleration here is negative 9.81. Okay, so I'm going to use, I think I'll use no t to find v, right? So v squared is u squared plus 2as, right? So the absolute value of v is equal to the square root of, basically u squared is 0, right? So it's going to be 2 times negative 9.81 times negative 7.25. I'll have to calculate that. Right. It's clear. So square root of 2 times negative 9.81 times negative 7.25. Obviously, you can just not type either negative and you're fine. 11.9266. Okay, but the fifth grader's going down, so we're going to make that negative 11.9266 meters per second. I'm writing a bunch of sig figs because I don't want to round. Okay, and then to find time, my favorite thing is to use s equals ut plus 1/2 at squared. I could use anything right now, but this one doesn't require me to use that velocity, so I like it a lot. Right, so that looks like comma. It's a comma. All right, negative 7.25 is initial velocity 0, right? So 1/2 negative 9.81 t squared, and then we can solve for t. Let's see. It's going to be the square root of 2 times 7.25 divided by 9.81. That's 1.215. 1.21576 approximately seconds, right? Obviously, not these digits aren't significant. I'm just writing down a ridiculous number. 1.21576, and of course we can cancel that across. 21576, and now we can use. Remember, these guys are the same. Whatever the initial is, the final is, and that's because the acceleration is 0. So now we can find this. It's just going to be s divided by t, right? So the formula is s is ut, right? So 6.80 is equal to whatever that velocity is times 1.21576. So 6.8 divided by the number on my calculator is 5.59319. 0.5931. How many sig figs? 1, 2, 3, 4. I'll say 2. 5, right? Or would round to 2. 5.5932 meters per second. Okay, so now I've identified the things that I knew, right? I knew this, and this. I calculated the things I could, basically fill in the table, right? Now we have to go to answering the questions. Right? So I calculated these things, right? And these guys are the same because there's no acceleration, right? So what time is a child in the air? 1.22 seconds. All right, what's the purely horizontal velocity? That's this guy. It's the horizontal velocity, 5.59. He's running for his life. Speed of impact. Ooh. Okay, so the speed of impact is basically the magnitude of your velocity vector. So look at this final velocity here. Don't look at the displacement, look at the velocity, right? So we're going to go over, wiki, and down, whoa, wow. And this is the hardest one of all, right? So don't forget to make that an arrow. Let's find the magnitude and the angle, right? So that angle is, this is 5.5, whoops, 0.5932, and this is 11.9266, right? And then the magnitude of this thing is square root of 5.5932 squared plus 11.9266 squared. Wow. Okay, I can do this. Square root of that guy squared. I'm using the up arrow on my calculator. I'm too lazy to type all those numbers in. Plus this guy squared. I'm getting 13.173. Right, so the speed is going to be 13.2 meters per second. Now I could find that angle over here, but it's not asking me for that. It's just asking for the speed of impact. How fast is it going? And that's going to be this hypotenuse. It's not this one. It's not this one. It's this, just the magnitude of it, right? The magnitude is 13.2 meters per second. All right.